Welcome to Vidyotma Physics. In this lecture, I'm going to discuss Gauss law in detail, concept along with questions which are relevant for NEET and JEE exams. What we are going to discuss: first, we will see what is an electric flux, then what is statement of Gauss law, what are important pointers regarding Gauss law. We will see some theory based question as well, and then various shapes. Often you are confused in various shapes. That confusion will be clear today, like cylinder, cone, hemisphere, cube, and various surfaces. So let's begin and first understand what I mean by electric flux. Electric flux I have anyway covered in a separate video, link you will find in description, but for now I will tell you simply that flux calculates what? Number of field lines perpendicularly passing through a area. I will write what is an electric flux. It is simply number of electric field lines which are perpendicular to surface. Let me visualize what I am saying. For example, this is our surface. This is kind of a rectangular surface. The plane, which is this plane, xz plane is there, okay, xz plane. And electrical fields are in this direction, in xy plane. What I said, electric flux is nothing but number of field lines perpendicular to the surface. So are these field lines perpendicular to the surface? No. Sir, does surface have direction? Yes, it has direction. Actually, this is the surface, right? So perpendicular to it, we take area vector. So direction of surface will be perpendicular to the surface. We define it by area vector. So what we have to do is, in order to take perpendicular field line, we have to resolve. So if I resolve field in two components, so one is along the plane, okay, and another will be perpendicular to plane. So can you see this component, cos component we are taking, E cos theta, so that I will get perpendicular field line. So what is formula of flux then? So formula of flux simply becomes flux is equal to, how we calculate number of field lines? It depends on three factors: electric field, area, and cos theta. So it is simply EA cos theta. This formula is valid when electric field is uniform, okay, and this theta is also same for all the points on a surface. For example, if I take electric field here, so again my angle is same. The angle between electric field and area vector is same, theta. So in such uniform electric field, we can directly apply this formula. Another formula is there that you need to understand for calculation of flux. Many times what happens is, electric fields are not uniform. See, this plus q charge is there and random surface will take. It is a three-dimensional surface, okay, three-dimensional surface is there. If I want to calculate electric flux, okay, mathematically if I want to calculate, what problem I have is that everywhere the angle between electric field and area vector is different. See, this is our area vector at this point, this small area I will take. This is area vector and this is field. Let us say this angle is theta 1, then this angle is theta 2. Similarly, this angle is theta 3. Angle is also different, and as well as field is also different. Why? Because it is not equidistant, right? Charge is not equidistant from all the points. In such cases, what we do is, we add this product EA cos theta. What I'm saying is, simply what we do is E1 ds cos theta 1 plus E2 ds. All ds areas, small areas we are taking which are equal, okay, cos theta 2, then E3 ds cos theta 3. So much we have to add. Instead of that, what I will do is, simply this is nothing but integration E ds cos theta. What is E ds cos theta? E a b cos theta. It is nothing but dot product. Yes, sir. So I can also write this as integral, close integral. Sir, why close integral? Because over a total surface we are taking E vector dot ds vector. So two formulas we have. One is for uniform electric field and another is for non-uniform electric field. Okay. So this is basic about flux. Now, what you need to understand is statement of Gauss law. Very important. Look here. What it says: the total electric flux through a closed surface, one by one, we will go in detail, okay, is equal to 1 by epsilon naught times total charge enclosed. What they are saying is, let me write mathematically. What was the formula for flux? So in general, whether uniform, non-uniform, I can directly write integration, okay. If it is uniform, then by integration also same result will come. So this was my electric flux, electric field dot ds vector. This must be equal to, they are saying, q enclosed divided by epsilon. We will understand one by one. First, they are saying closed surface. Now, what is closed surface? I have a confusion. Yes, I have confusion. Let us say this is a 2D surface. It is a circle, okay? And another, let us say this is a 3D surface. If I keep charge here plus q, and if I keep charge here plus q, okay, it is a 2D. And sir, what is this? 3D. You will say, sir, both are closed surface. No. What I am saying is, which surface they are talking in Gauss law? They are talking about closed surface 3-dimensional. So here I will say flux is equal to what? Q upon epsilon naught. Perfectly fine. Flux through all the surfaces. 3 surfaces are there. Okay. 1, 2 and 3. It is Q by epsilon naught. But here I cannot say that flux is equal to Q by epsilon naught. Actually, if you see these are electric field lines. Okay, sir, understood? And all electric field lines are perpendicular to the surface area, yes or no? This loop is in which plane? XY plane. Its area vector will be outwards towards you. So what is angle between area and electric field? 90 degree. So here actually what is the flux? Here it is 0. So first point what you understand is closed surface means 3D surface they are talking about. Okay, fantastic. They are saying another thing, total charge. Sir, what is meaning of total charge? Let's say, again I am taking a 3D surface, okay. Now this is a 3D surface. Now whenever we will solve, mainly it will be 3D surface. Let us say I put some charges here. 2 coulomb charge is there. This is minus 1 coulomb and this is 4 coulomb. And if I want to write expression for flux through the surface according to Gauss law, so which charges I am going to take? Total charge enclosed. When I say total charge enclosed, charge is a scalar quantity, right? So directly whatever charge is inside the surface you are going to add. So I will write 2 plus minus 1 only inside matters, okay, not outside, and divided by epsilon naught. So what is my flux? Sir, 1 upon epsilon naught. Are you getting? Pointer number 1, closed surface means 3D surface. Pointer number 2, very important, that total charge is nothing but scalar addition of all charges within the surface. Okay, that is important. What next? This is important. What they are saying is that the flux is independent of shape, size of a surface. Sir, what is meaning of this? We are not getting. Let me explain. Let us say this is my surface. This is my 3-dimensional surface here, and this is another surface. Let us say we take a cylindrical surface, okay, or instead of cylinder what we will do is we will take sphere, okay. 3D surface I am talking about, okay. So this is a 3D. Plus q charge if I keep, and here also plus q charge if I keep, phi 1 and phi 2. You tell me where the flux is more. Phi 1 greater than phi 2, phi 2 greater than phi 1. Both are equal. Yes, what they are talking about is it is independent. Why independent? What Gauss law says? Flux only depends on what? q enclosed upon epsilon naught. So here also what is charge enclosed plus q, and here also what is charge enclosed plus q. That means my flux are equal. Are you getting it? And if we go conceptually also, flux is nothing but what? Number of electric field lines passing. So here for plus q, whatever number of field lines are originating, they will be same for both, because number of field lines is directly proportional to magnitude of charge. Yes or no? Basics you know, right? Electrical field properties. So they are not going to change. Very good. Another. Okay, it also does not depend on the size. What I'm saying is, let us take another example. Suppose this is a sphere, plus q charge I keep at center. Okay, I will draw another sphere. Another sphere if we draw. Okay, now you tell me, this is number 1 and this is number 2. Okay, it is a symmetric, by the way. Let us draw a little properly. Okay, more or less it is same. Okay, so this is number 1 and number 2 is there. Fine. Now you tell me, here phi 1 is equal or phi 2 is, what is the relation between phi 1 and phi 2? Who is greater? You will say both are equal. Why both are equal? Because charge enclosed inside small sphere and big sphere both are same. So flux are equal, and what is that equal to? Q upon epsilon naught. Finish. And is it simple? Yes, very simple, but these points are necessary. Okay, then independent, flux is independent of position. What I'm saying is, let us say, so here what I do is, we'll take another surface. Sir, what is that another surface? Let me discuss. So let us say this is one surface and similar surface is this. Okay, first what I do, I will take charge plus q at center and then plus q just inside the surface. Now you have to tell me in which case flux is more. For these two, again phi 1 is equal to phi 2 is equal to q upon epsilon naught. Does flux depend on location of charge within the surface? No. What Gauss say is, whatever charge is inside surface, doesn't matter where it is, flux will be q upon epsilon naught. Are you getting it? So 3 very important points we learned. What are the 3 points, sir, regarding flux? Number 1, does flux depend on the shape of the surface? No. Size of the surface? No. Location of the charge? No. Are you getting it? Very good. This is important point. Electric field, when I talk about electric field varies as per distribution. Very conceptual point. See what I'm trying to say. If someone asks you that at this point, let us say at this point and another point, is electrical field same? I will say no. Why no? Because the distance is not same. Are you getting it? Electrical field is different, but flux is same. See here, suppose someone asks me what is electrical field. Let us say this is point number 1, and here also similarly we'll get point number 2. I will say electrical field at 1 is greater than electrical field at 2. Why? Because distance is less. But flux in first case, total flux for the first case must be equal to total flux for the second case. Are you getting the concept in your head? Okay, fine. Let's go to the next part. What next part is saying? Yes, very important. So whenever we write integration, close integration of E dot ds, which is nothing but flux, we write q inside upon epsilon naught. Flux is always due to inside charge. Let me visualize. You suppose this is our spherical surface. Let us keep some charges. Okay, sir. Here q1, q2, and let us say here q3 is there. You tell me one thing. Flux is due to, flux, if I talk, flux is due to which charge? q1 comma q2. Will it be due to q3? No, 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 it will not be there. Why? Because it is inside, right? Only inside flux is due to inside charge. But when I say electric field, suppose I'm asking you what is electric field at this point. So let us say this is point number 1. So electric field always remember electric field will be due to all charges. Why all charges, sir? Why all charges? Because see here field line will be there due to Q1, here due to Q2 field line will be like this, and due to Q3 field line will be like this, and net field, let us say this is E1, E2, E3, and this is point A. So when I write EA, it is nothing but vector addition of E1 plus E2 plus E3. Are you getting it? Electric field is due to all charges, whether it is inside or outside, but flux is due to only what? Charge within. Okay, so electric field is due to Q1 comma Q2 comma Q3. Perfect? Yes sir, perfect. Next, my question to you is, can I say that if my flux is 0, then electric field is 0? Think. Can I say, suppose flux is 0, sir, what is flux? What is the formula of flux? So formula is flux is integration of E dot ds. So if this is 0, can I say that E is also equal to 0? Is it correct? No, it is not correct. This is maybe. Maybe. There are other cases possible as well. Let me show you. So for example, let us take. So here, if I take this circular loop, okay, this is circular loop, and let us draw beautiful field lines. Let us say these are electric field lines. Now you tell me here, what is the value of electric flux? It is 0 or non-zero? Sir, where is area vector? Area is like this. What is this angle? 90 degree. So what is value of flux? Value of flux is 0. Yes, 100% it is 0. But is electrical field 0? No, it is not 0. Here E is not equal to 0. So this is 0 due to what? Due to theta is equal to 90 degree. So whether my flux is 0 or not, it depends on orientation as well, not only electric field. Are you getting what I'm trying to say? Another beautiful example I will give. Suppose, let us say this is a spherical surface. Okay, sir. Here is charge plus Q and it is charge minus Q. Okay. If I ask you, what is electrical field at this point? What is electrical field? You will say, see, due to plus Q it will be outward, and due to minus Q also it will be outward. Sorry, inward it should be, sir. Minus means electrical field is inward. Okay, sorry for that. So here, if net field is asked, net field resultant. So if, sir, resultant is asked, how resultant will look like? So resultant will look like this. Yes sir, agreed. Resultant electric field at that colored point will look like this. Flux is 0 through entire surface. Here you tell me flux is 0 or not 0? Flux is 0, sir. Flux is equal to Q minus Q upon epsilon naught. It is 0. But is electrical field 0 at that point? No. Electrical field, let us say this is point A. About A point I am talking about is not equal to 0. So whenever statement comes in exam, if field is 0, then flux is 0. Sorry, if flux is 0, then field is 0. It is true? Not true. Are you getting it? But if I say, if E is equal to 0, then can I say phi is equal to 0? Is this correct? If electric field is 0, flux is 0, 100%. This is 100%. Why, sir? Because here if you put 0, if electric field is 0, what you are going to do? See, flux is nothing but what? Number of electrical field lines passing through the surface. If electric field is 0, so no electrical field lines are going to pass. Are you getting this? So if electric field is 0, flux is 0. But if flux is 0, electric field may or may not be 0. Fantastic, sir. So this is important. What they are saying is that for a closed body, again which closed body I am talking about? 3D body. Okay. If charge enclosed is equal to 0, then flux for both uniform and non-uniform electric field is also 0. What is meaning of this, sir? We are not getting. Let me explain. Let us say this is our any body. Let us say this is a spherical body. And here are the electrical field lines which are passing. So these are electrical field line passing and coming outside, then coming outside, and here also coming outside. If someone asks you that what is the flux? What is the flux through sphere? Spherical surface. What is your answer? I will say the answer is 0. Why 0? What is the definition of flux? Gauss law. Q upon epsilon naught. Mathematically how we calculate? Is there any charge inside? No charge is there. No charge means what? Flux is what? 0. Or you can also say that, here number of field lines incoming, they are equal to number of field lines outgoing. So if number of field lines which are incoming and which are outgoing, they are same, then is flux 0? 100% it is 0. Are you getting it? So whether it is uniform field or non-uniform field doesn't matter. Let me give another example. Okay, sir, another example. Let us say this is a circular surface, and if we keep here plus Q charge, okay. Now you tell me, electrical field will be like this. Okay, sir, agreed. Here again same thing. These are inside. Number of field lines which are going inside, it is also equal to number of field lines which are coming outside. That's why here also what is the flux? It is 0. Are you getting it? So charge must be there inside the closed surface, then only flux will be non-zero, else it is not 0. Else it is 0, sorry. So let me give example. See, through different examples we are going to understand. Let us say, sir, here, if you take the surface, now the charge is enclosed. Let us say plus Q charge is enclosed. Now is my flux 0? No. Here only electrical field lines are going outward. No incoming electrical field lines are there. So here flux is what? Flux is not equal to 0. And if you want to write what is flux, it is simply Q upon epsilon naught. So always remember, for a 3D closed surface, if there is no charge inside the surface, electrical flux is 0. Are you getting it? Okay. Very good. So when Gauss law is valid, another important question comes in your mind. See, these are all direct pointers which can be asked in NEET and JEE examinations, okay? Because I have discussed Gauss law in detail, and this much detail explanation is needed to cover syllabus entirely, okay, properly. Here, I will ask you one thing. Sir, two surfaces. This is one surface, and let us say this is another surface. Here it is plus Q, and here also it is plus Q. You tell me in which case Gauss law is valid. In first case or in second case? Sir, Gauss law is invalid in first case but invalid in second case. No. Does Gauss told in the statement that my surface should be symmetric? No. That means here Gauss law is valid for both the surfaces. Are you getting what I'm trying to say? Here I will write valid, important, for all closed surfaces. Always remember that my expression, this expression of Gauss law, is valid for all closed surfaces. Don't worry. Are you getting it? Using this, I can calculate electric flux through all closed surfaces. But what happens is, some closed surfaces are not used for calculation of electric field. What was the purpose of Gauss law? Gauss law was brought so that electrical field lines can be calculated easily. See here, electrical field can be calculated easily. Here integration is there. We have to avoid the integration. That's why Gauss law came. Are you getting it? Easy calculation for flux as well as electric field. But here electric field calculation is difficult. Here it is easy. Let me explain. What I'm trying to say is, suppose I want to calculate electric field at this point. So how electric field lines will be? Like this. Okay, very good. So whenever I will write expression, what I will write, integration of E dot ds. You tell me, is electrical field same at all points? Yes, it is same. Why? Because surface is symmetric. So I can simply write E ds. What is angle between area vector and electric field? You tell me here. What is angle between area vector and electric field? Sir, here area vector is like this. Area vector is like this. Area vector is like this. That means here theta at all places is 0. Do you agree with me? Yes, sir, definitely we agree with you. Then I will simply write cos 0. And if you integrate this, so this is 1, E will come outside. So I will simply write E integration of ds, which is equal to what? Es. And you write this closed integral as q upon epsilon naught. So directly I will get electrical field from here. Anyway, I know area of this surface, right? Sphere, it is 4 pi r square. But here it is not applicable. Why not applicable? Because please try to understand that here electric field lines is like this. Is my electrical field same at all places? Electrical field same, E not same. Okay, you tell me what about theta? Sir, here if we draw area vector, so how is area vector here? Outside. Here also, let us say this is tangent, this is my area vector. Here area vector. So area vector is also having different angle. Okay, even I will write that theta not same. That means we have to do this close integral. Are you getting it? How to do this close integral? I cannot integrate because the function is very random. Are you getting it? What I'm trying to say? Do you know what is electrical field? That's what we have to find. Application of Gauss law. Sir, area, I don't know what is area. Do I know all theta? No, I know. I don't. So here, this calculation is not practical. Are you getting it? So electrical field can't be calculated. What I am saying is, whenever the surface is symmetrical, then Gauss law is valid. Asymmetrical, then also Gauss law is valid. But calculation of electric field is only possible when everything is perfect in the place. Angle is also same, area is also, every area is same, and in fact the electrical field magnitude is also same. Are you getting it? And for calculation of electric field, we take a special surface which is called as, what is called as, sir, Gaussian surface. Are you getting it? Gaussian surface. Sir, what is a Gaussian surface? So Gaussian surface is an imaginary closed surface for calculation of electrical field. Some conditions are there. What are the conditions? It must be symmetric about charge. I will show you. Okay. And angle between E and A either 0 degree, 90 degree or 180 degree. Let me show. Let us say I have to calculate electrical field. This plus Q charge is there. So Gaussian surface for this is what, sir? So Gaussian surface of this charge is simply a sphere. Are you getting it? If I draw electrical field lines, how electrical field lines are? Like this. Just now we have discussed. Yes, sir. These are electrical field lines. Now you tell me, is our electrical field calculation possible? Yes, possible. Why? Because see here, what is angle? Angle between area vector. At all points, if I draw area vector, what is angle? 0 degree. So easy to calculate, right? 0 or 180 degree, easy to calculate. See, my goal is to make this calculation easy. Our goal is to make this easy. And how this is possible? This is only possible when theta 0 degree, so directly EDS I can write. And also electrical field symmetrical. If charge is symmetric about surface, then electrical field at all points is same. Yes or no? Here also electrical field is same, here also same, here also same. So practically I can directly write this as what? EDS or ES. That is my goal. Are you getting it? So this is perfect Gaussian surface for a point charge. And from that only we can derive the electrical field. Then Any other example of Gaussian surface? Yes, we have. What is that example, sir? So line charge, you know what is line charge? Yes, sir, we know what is line charge. So a single line is there. Let us say this is line and this is positively charged. If I want to take Gaussian surface, how surface will look like? Now here you should remember that surface is cylindrical in nature. Like this symmetrical cylindrical surface is there. Are all conditions satisfied? Yes, satisfied. You tell me how electrical field lines will look like. So these are like electrical field lines. Okay. Here it is outward, again outward, outward, outward. Okay, sir, what about area vector? Where is area vector? So this is my area vector. Area vector is also outward. Come on. This is a curved surface. Okay, it is a cylinder. Can you see this? So if this is a curved part of cylinder, curved part, so where is area vector? Towards you. This is area vector, right? Area vector is this, and field is also radially outward only. So what is angle here? Angle is 0 degree. I will write here theta is what? 0 degree. Then I will say E is same for all points. Are you getting it? E is same for all points. That is the symmetric charge distribution. Are you getting? So I can perfectly say this is a correct Gaussian surface. So suppose, let me ask you one small question. It's a plus Q charge. Let us say, can I take, suppose in exam they ask that this is a plus Q charge and can cone be Gaussian surface for plus Q charge? Now you don't know what is Gaussian surface. How you can tell? Such questions are also asked. So here answer is what? No, it can't be. Why it can't be? Because electrical field you can see is different at all points, because this different distance is different, this is different, this is different. So it is not symmetric charge distribution. Are you getting it? And also another thing is angle is also different. Okay. So this is about all properties we have studied in detail regarding Gauss law. Let us revise one by one. Flux depends only on what? Charge inside, because flux is what? Q upon epsilon naught. Q enclosed upon epsilon naught. Point number 2. What? Is it dependent of shape, size and surface? No, sir, it is independent. Very good. Okay, does charge depend, the flux depends on the location of charge? No, here again it is independent. Okay, sir, getting, sir, very good. Okay, flux is equal to Q upon epsilon naught. Electric field is due to inside charges or outside or both? Yes, electric field is due to both charges. Very good. You have become lot of intelligence. Lot of intelligence. Okay, sir. Inside plus outside. Flux is due to what? Only inside, sir. Very good. Very, very, very good. Okay. If charge enclosed within the closed surface is 0, if charge enclosed is 0 within a closed surface, 3D closed surface, then flux is what? Flux is what? 0. Are you getting it? Okay. Gaussian surface. What are the characteristics of Gaussian surface? Can you tell me? 2 characteristics. What? It must be symmetric. And what is second? What is second? That theta should be only 3 options: 0 degree, 90 degree and 180 degree. Finish. Nothing beyond. Almost 99.99%, 1.001%. Data also take that error. Okay, so almost 99.99% points we have covered in Gauss law.